Good afternoon. I'm back again with chemistry. My name is Ngagaralekwala, physical science teacher at St. Bernard's High School. So today we are going to focus our revision on electrochemistry, and then we'll finish off with the fertilizer. So what I want us to do is, before we can go any further, if you can have your exam guide next to you so that we can review what is on the exam guide and also make sure that there's nothing that we leave behind. So I just want to focus your concentration in your mind on the exam guide, and then from there we will see what the interpretation is from the exam guide, looking at some of the questions that have been asked in the previous questions. All right. So if we look at the exam guide, looking exactly at the electrolytic and galvanic cell, which are the two cells that we have to concentrate on. That is, this is electrochemical reaction. And they say here, you should be able to define the galvanic cell. And then what happens in this cell is the conversion of energy is from the chemical energy to electrical energy. In other words, we get the chemical reaction taking place, and then this chemical reaction results in the electrical energy being formed. All right? So sometimes we'll talk about the galvanic cell or the voltaic cell. This is the cell where the cell is able to sustain itself. And what do we mean by that? We mean if the reaction starts, the cell is able to, the chemical reaction will be able to continue on its own without you hampering the reaction by maybe putting the cells in there so that the reaction can take place, or some sort of change in the energy conversion. So in this case, we've got the chemical reaction where your chemical energy is converted into the electrical energy. All right? And then you must be able to define the electrolytic cell. And then with reference to what we just talked about, the galvanic cell, the electrolytic cell, that's where the electrical energy is converted into the chemical energy. And now, if you look at the two cells and you think about the form of question that can come up, how do you differentiate now between the galvanic and the electrolytic cells? If you've got on the components of your cell, if you've got the power source, you must know that the energy is converted from that power source into the chemicals. In other words, your electrical energy is converted into the electrical energy. Then you must be able to define the oxidation and the reduction in terms of electron transfer, where we define oxidation as loss of electron and reduction as gaining of electrons. Now, later I will show you how do you go about reminding yourself about the two. And then from the definition, you must also be able to identify your oxidizing agent and your reducing agent, and also use the grade 11 information in terms of defining oxidation and reduction in terms of the oxidation number. Now, in terms of oxidation number, there you look at the charges. If the charges, if the oxidation number increases, in other words, if it moves from neutral, where you don't have any charge, to a positive charge on the other side, you will know that the oxidation number has increased. So if it gets increased, that type of half reaction we refer to as oxidation. And then reduction, the decrease in the oxidation number. All right? And then define oxidizing agent and reducing agent in terms of the type of reaction that they are responsible for. And then define the electrodes as the anode and the cathode. And the anode, we say that's where the oxidation takes place, and the cathode is where the reduction takes place. And then from there, you'll be able to define the electrolyte as a solution that is able to conduct electricity through the movement of ions. So sometimes you can ask your question here, why do we have to put the salt in the solution? Your answer comes from that bullet where we say the electrolyte is a solution or a dissolved substance that conducts electricity through the movement of ion. So the salt, we are putting it in a solution so that it can ionize, so that you can have the ions moving, and then the movement of ion will enable the conducting of electricity. Then the last bullet here is electrolysis. This is where electrical energy is converted into chemical energy, or we use the electrical energy to produce chemical change. So also with this, you should be able to see as we go on, you should be able to look at this in terms of the application of the two cells. All right. So let me just take you quickly through the summary of what we just went through. The electrolytic and the galvanic cell. If I can just make an example here with the galvanic, starting with the galvanic cell. All right. How do you know that's the galvanic cell? You have two beakers, and then in these two beakers you'll have your two solutions. All right. And then in this solution we dip in the electrodes. All right. And then you'll also have the galvanometer or the voltmeter. Let's put the galvanometer there. And then the galvanometer is connected to the electrodes. All right. So we refer to this as our external circuit. And then we also should have a salt bridge. All right. So the salt bridge, what it does, we'll look at the function of the salt bridge as now. So if you've got a cell like this, then you've got a complete cell. So let's say in here, the usual one, we've got zinc sulfate. And then in here, we've got copper sulfate. All right. So this is the solutions that we have in the two beakers. And then if you've got zinc sulfate in here, this electrode should be a zinc electrode. And then that one inside the copper solution, it's a copper electrode. All right. So now what happens is, if you've got these two cells, you should be able to use the electrode potential table. Let me just find it quickly so that I can explain to you how we go about using this table. Different schools, they use different tables. There are two tables in your exam in your exam timetable. No, in the exam guide, also in the question paper. So the one that I prefer to use is 4B. So how do I use 4B? If I identify my two half reactions on the table, the one on top is oxidation, the one at the bottom is the reduction. So let's look at this. Remember, if you've got this reaction taking place in this solution, you've got your zinc ion, Zn2+, and then you've got your SO4 2-, and then in here you've got your Cu2+ and your SO4 2-. All right. So the electrode, I mean the salt bridge. The salt bridge, in there you should have the solution that cannot form a precipitate. So if you look at your grade 10 syllabus and then you look at the solubility rules, you will remember that the nitrates are all soluble. So the one that will be suitable here, let's say for an example, we put potassium nitrate. You know that potassium nitrate is dissoluble, so it won't form any precipitate. All right.